Okay, so you are accepting the numbers first and you are dividing into each part. Okay, perfect. Okay, so can you go to multiplication or addition or subtraction, any one of them? Again, you're taking the same multiplication. Okay, this you have tried in different way. You're while accepting numbers, you are multiplying each and everything and okay. Can you go to subtraction once? Okay, here you have done in different way, taking all the numbers and then subtract. Okay, can you go to addition? Akila, can you go to the next one? Addition. Okay, you have taken this. Okay, perfect. I mean, you have tried different things and you have tried even the parameter over here, console.write line of result of so and so parameters. Good. Yes, I've tried. Can you just run this once again, Akila? I just want to show something different in this. Okay, can you press option 7? Enter. Oh, cool. Can you go back? I can't see this invalid option. Where is that? Can you go to your program once? Oh, is it in default case? Is it in default here? Perfect. Good. Cool. So at least for numbers, your program will not break, which is very good. Cool. You have tried enums. You have tried converting your number, whatever you do, typecasting it to enum. Yeah, it's a very good program. That you have typecasted your enum based on your input. Right? So that is something which I can see. This is a very good one which you have tried. Good going, guys. Okay, Sharda, you want to show your assignment now? We'll see. So today we're going to start with OOPS, which is object oriented programming. Right now, before actually starting up with different concepts of OOPS and all, right? Let's first understand what is OOPS and how it is different from other programming models now. So in general, right, we normally hear two different, words normally. We normally call things like OOPS and something called object orientedness, or we normally call something called a language which supports object orientedness, right? Now these two things are different differently, but they are actually related to each other. So how it is take an example of C++, that is both the legacy ones. So if you take an example of C++, right, now we normally call C++ is an object-oriented programming language, right? That would be I was saying object-oriented programming language. So what is the difference between object-oriented programming and object-oriented programming language? Right? Mainly, object-oriented programming is a pattern how we write program, or a certain design or certain rules, right, being formulated that we can actually create a program in this manner. Right? Basically, we normally create an object-oriented program to reuse the code. The main objective of OOPS is to reuse the code in a best possible way. Right? It's a single-centric usage of OOPS, which is code reusability. Right? Now, which means in order to write any OOP or object-oriented programming, we need a language to support a class and an object. These two are very important. if any language doesn't support creating a class and creating an object of that class, then you won't be able to write object-oriented programming in that development platform. Now, a language which supports creating a class and object, right, can support object-oriented programming pattern. Now that language is called as an object-oriented programming language, which means, take an example of .NET. In .NET you can create a class and object. So that's the reason why our .NET is object-oriented programming language. Right? Where I can create class, where I can create object. Now in turn I can create program which completely obeys OOPS patterns. Now this is the main thing which we have to understand. That's the reason why, if you take an example of C, in C it's a complete flat, plain files we write and directly execute them in Turbo Engine, and each file will give output. Right? You can't create a class and object in C. That is the reason why C is not an object-oriented programming language, where you can't write any of the code. Right. Now we said that OOPS is something which is mainly centric for code reusability, right? Now if you want to reuse code, which means you have to write code in some entity, right? So that entity is nothing but class. We write code in class. We have already seen this part, like we already wrote a program, right? You can see that, right? So in the same class, I created one class and I'm using this class again in my some other class. Also, the same class I'm using across my libraries. Now this is the main use when you create a different class. Now, basing this advantage, right? This advantage, we have something called some patterns which you can follow to make it more robust. Right? So that is about object-oriented programming patterns we have. Right? Now, in general, we have 5 different object-oriented patterns or OOPS concepts. So rather, we normally divide it into 4. So the first one is encapsulation. Second is polymorphism. And we have here we'll see polymorphism next to inheritance. So let's take inheritance first, and then you have polymorphism, and then let's say you have abstraction. Abstraction interface. Let's see both. Now we'll actually see what is abstraction, what is interface in our 4th section, right? So let's see all other stuffs like what is encapsulation, what is inheritance, what is polymorphism, and what is abstraction, and we'll see the interface one. Like how can we create any interface in .NET and how we can actually use it. Right? Now, let's start with the first one, which is encapsulation. Now, what is encapsulation? So, encapsulation is nothing but you want to hide some data in some situations and show that in some other situations, which means I'm going to use same class for different purpose, where based on my requirement I will expose the data, based on some other I will not expose. How can you actually expose some data in some situations and some situations not? Now you can see if I make a variable private, right, what is happening here? I can't access this variable I in any part of my code outside this class. It can be in a same library or across the library or wherever it is. If I define something private, which means I'm hiding it completely, right? But the same variable, if you make it public, what is happening here? Right? Here you are actually exposing this to the entire world. It can be in the same class or the same library, right? Or it can be in the same in the same library, but you are using across different libraries. So in this way, you can actually have them hiding. But here you can see that I can't declare same variable in two different ways, right? Which means I can't hide this I and also show that. Obviously, I'll have to follow some pattern so that I can actually make it work, right? So that working model encapsulation will keep that. Let's see how to do that. So let's take some use case here. So let me create a separate project. Now I think you understood project creations and how to make it start up and all, right? So let me create a project in groups. Let me make it as startup project, right? Now perfect. So here what I'm going to do here is, let's take a use case first. A simple use case in encapsulation. Now let's take an example of salary, employee salary, right? Let's say in a company, in a firm, you have three different roles, like team member, let me call it as T, and this manager M, and let's say admin, right? So team members, we have managers and we have admins, let's say, right? So let's say we are designing a salary class, right, which serves some purpose. So salary class, what you can do, you can get salary, which means you can actually retrieve, see the salary, and also you can modify the salary, let's say. So these are the two things which you can do, two different tasks which you can do out of your salary class. Now, so I want to design one single class to serve purpose of all different roles. That is something which we are going to do now, which we are going to see now. Now, so your team member, let's take each and every use case. When you have a team member, right? Now when you take a position of team member, so one team member will not be able to see salary of other team member. Am I right? Yes, obviously. So if we are colleagues, right, and obviously I can't see your salary and you shouldn't be able to see my salary, which means your salary class should be intelligent enough to differentiate between your roles. That's the first point. Second point, when it comes to manager can see salary of a team member, or rather normally whenever it is a manager role, he can see salary of, let's say, your team member. Now let's be more specific that your salary class is specific to getting salary of team member, right? Which means a manager can see salary of team member. Now here, if you take a use case in this way, your team member so will not be able to see. Let's take this as that view salary. Now here your team member will not be able to see, but your manager should be able to see, which means yes, manager can see and also admin can see, right? Now view edit. Let's say edit option. One team member will not be able to edit salary of other team member, which means again team member should not have access. But manager also should not have access. Manager can give only promotion. We'll say that okay, you got promoted, but who will actually edit salary? Admin, which means manager also doesn't have. I'm just taking an example, guys. In some firms, maybe manager can have access to edit, but I'm just taking a use case that, right? In the edit option, a team member cannot edit, a manager cannot edit, and your salary can be edited only by admin. Which means admin is the one who is like a main administrator of the complete salary or different modifications in a company. Now let's design this and see how it's going to work. So let me create a new class called salary. So here you have a salary class. Now So I'm going to take a variable. Now obviously what is that we are actually talking about everywhere? Salary, right? So let's take a private, let me just call it as a double salary or salary. So initially let's say the salary is some equal K. Right? Now this is the initial salary I said. Now you can see that it is a private variable which I have done, right, which means in my program, let's say this is a program which is a calling program for a manager or team member or anyone, let's say, right. Now here let me create a salary object, let me call it as obj is equal to new salary. Now here if you see, I won't be able to access my salary. I can't. Why? Because this is not exposed. Now firstly, let's see how we can actually make one single variable, right, get exposed in some situations and cannot in some other situations. How? Now this is something which is a tricky part. Now here you have an option to create a property of a variable. Now when we say property of a variable, what does it mean? Right? Now here you can see that I want to create a property of salary. Now property is nothing but your getter and setter property. We can create properties for different variables. It can be any variable. It can be a data type variable or an object variable or any type of variable. We can create something called get and set property. Let me show you how to create a property, then I'll actually explain that. Now in order to create a property, either you can directly write it down or select your variable for which you want to create property, and you have a shortcut called Control RE. Control RE will actually take you to the property name. So I want to create a property with a name called sal1. Okay, that's fine. I can actually make it work. Or if you want to change name, yes, always you can change. Let's say you want to change it as sal or PRP, which is PRP salary, property salary. You can't, okay. Now it will say, do you want to encapsulate? See here what it is saying. Do you want to encapsulate sal as so and so? Now our property here is nothing but, yes, I want to do some encapsulation work. And click on apply. Now you can see this is called as a property. Now you can see the model of your property is same as your method. Only thing is you will not have your braces. Now if you take your braces, then it will be a normal. Now this we will not do. Now here how does it work is it will have two main components called getter and setter. Now by the name itself you can understand that getter is nothing but whenever you call this property it will get the data. Now you can see it is taking the variable called sal. Now the sal variable is exposed through the property using get. Same way your sal will be set using your properties. Right? Let's see this. I'm not going to create any role as of now. First let's see how it works. Now you can see here that your property is a public one. Right? Which means I can at least access this property. Now firstly let's get the data. We have console.writeLine. Now you can see when I say obj dot, you will see that PRP sal. That's it. When you call this property based on the situation. Now here what is the situation of property? It is trying to get the data. Right? Now whenever it is trying to get the data, then this block of code will be executed, and you can see it is we are seeing return of salary. Now what is the salary? Here you can see salary is 12,000, which we have. Now this will be returned and will be printed over. Right? First let's run this plot. Run this. Right? You can see 12K. Got retrieved. Same way, let's say I'm going to change it. This is obj.prp. Same, use the same property and just change it to so and so. Now you can see whenever you are trying to assign a value to a property, right, then automatically it will actually go to set, and you can see the value. Now you can see that this is a inbuilt value key or token for a property, and the value whatever you are setting here will be automatically set to value, and in turn it is actually we are actually assigning it to sal variable. Now this is how it works. Now once you are setting the salary, then print it again, see what happens. Right? You can see that yes, we are getting the data. Now this is called as an encapsulation. Mainly this is an encapsulation. We are encapsulating variable, right? We are not exposing this variable, rather what we are doing, we are actually exposing the variable in terms of properties. Right? Now you can actually blow the situation here. Let's say what I am going to do here is, let's say I am going to create roles, right? So here what we'll do, let me create an enum here. So this is something which is an encapsulation. We are hiding some data and providing some data whenever it is needed, right? Now here let me create a public enum. I'm going to create an enum so that we have already done with enum, right? You know enum is much better. Let me call it as role. So here let me call it as TM, which is team member. Let me call it as manager, and let me call it as admin. Like we have these roles, right? Now what I'm going to do here, I'm going to use the public enum variable as current, I'll say CURA underscore role. Now this is very important to me, and by default what I'm going to do here is I'm going to do something called role.team member. By default, if user doesn't set any role, then I'm going to take it as a team member role. Oh, sorry, it is not even, it's role. My bad. Right? Obviously, right? Here we have to create a variable for my role. Now I have this, which means after creating an object, right? After creating an object, let's say if I don't assign any value to current role, then it's not going to work. Now, how I'm going to use this? I'm going to use this here. What I would say, if my current role is equal to role dot. Now who can see the salary? Manager, or remember this, right? This is a logical operator which I have written. Or your current role is equal to your admin. Role dot admin. If these two guys are there, then it will return something. Otherwise, else I'll return just a 0. Right? Now, while returning else, let's say I'm going to type in something called console.writeLine no access. Right? Now, which means now you can see my program actually becomes more robust. Now, what I'm doing here, in my salary class, I created a simple role, and by default, you can see I've set it to team member. Now here, it is very important whenever you create an object, right? Whenever you create an object, it's very important that you create you have to assign who is the one who is actually accessing this. Now let's say your current role is equal to your role dot, let's say initially I'm actually making it team. So we have done, a complete security for my getting data. Now how about set? Who can set? Only an admin, right? If your current role is your admin, he can set, that's it. Remaining guys cannot set, right? So let's say else, let's say console.writeLine no access, no edit access, right? Simple. Now what we have done, we have created a role, and what we are doing, now you can see in some situations we are showing data, and in some situations we are hiding data. Same way, in some situations we are actually allowing user to save, in some situations we are not. Now you can see I'm actually providing same class for different roles, which is encapsulation. Right? Come back here, and now you can see that yes, I am giving a role as team member. What does it mean? team member will not be able to get the data, right? I'm not going to touch these things, these three, because what I'm doing, I'm getting data here, I'm assigning some data, and again I'm getting data. Let's run this and see what happens. Now you can see it says no access, no edit access, no access. You can't get the data, you can't edit the data, or you can't get it again. Right? So this is what these are. This is how we encapsulated everything for a team. Now let's give a role as manager. Run this program. Now you can see manager can get the data. See here, whenever he is trying to get, yes, he got at 12,000. Now whenever he is trying to edit, now you can see he doesn't have any edit access, no edit access. That's the reason why, again, whenever you try to get the data, he is getting 12,000. This is about our manager. Now, what happens if it is admin? Now let's also create this admin. Now here, whenever he sets some data, let's create something like console dot right line of new salary updated, and update the new salary. Right? Now this value is nothing but, don't worry about this, this is something which is an internal key token of your properties. Whenever you create a property, this value is nothing but whoever tries to assign this, it will be automatically assigned to this value. Now what I am doing to the admin role, I am assigning my salary to the new value. Now let's change this to admin and now run this. Now you can see 12,000, and whenever we try to change, update it, and you can see the new salary again at 50K. Now here you can see one class is serving multiple purposes, right? And how is this possible? By encapsulating your data. So this complete pattern, now the model, how we actually wrote the complete program, is called as an encapsulation or encapsulating data. Right? So in spite of making this variable private, right, we are actually, we wrote in such program in such a way that we gave access to world whenever it is needed, and we restrict it whenever it is not needed. And this is how we do encapsulation, and that is the Hadoop concept called encapsulating or encapsulating your data. Fine. So any questions in this encapsulation, guys? So if there are no questions, now let's move to the next one, which is inheritance. Now what is inheritance? Now as the name suggests, right? So here, as you can see the name inheritance, which means you can actually get the features of other class to the class which is child, which means inheriting something, right? Parent, right, is there, and the child is there, where you say child inherits features from the parent, right? That is the inheritance. Same model we also follow in here, right? One class include a feature, right, where if you inherit that class to the second class, where you can see all the features or all the variables or all the members you can actually use directly into your child class. So that is called as inheritance. So here you have few restrictions that one class can inherit only one other class, which means we will actually come to that, which is called as a multi-level single inheritance. So this is the only possibility. I'm giving this because if you know OOPS patterns in C++, right? In C++ you have multi-level multi-inheritance. One class can inherit any number of classes, right? But here, no, that is not the case over here. So here, first let's see a simple example of inheritance, then we'll actually get back to the multiple concepts over here, right? Fine. So let me create a simple class. Let me close all. Let me create a new class. here. Let me call it as parent. I'm just calling it as a parent class. So here let me create few variables, right? So here let me say I have static void of let me create one more class which is trigger class. Let me create a trigger class here. So in this class now, so here we have a static void main. So we have string array of A, right? You have details, which is good. Now you have a class parent. So here your class parent. Now let's see. If you remember, we have already done this. Now if you remember in our access modifiers, right? We have created class A class and B class, and we have used A class and B class, right? Same thing we are going to do here. Now let me create one more class here called child. But we are going to see more complex things in what we can actually do in inheritance. So here let me create few variables. Now what I'm going to do is, we already know access modifiers, right? If you create anything in private, we know that we are not going to, we cannot access them from child, right? In the same way, if you create anything protected, right? I mean, I hope you guys know about the access modifiers by now. So what I'm going to do here is, I'm going to, as we have to concentrate more on inheritance part, and what I'm going to do here is, I'm going to concentrate more on accessing the variables directly, right? So which means I'm going to actually use child first or parent first. So here what I'm going to do, I'll create, everything will be public as such. I'll create public if I is equal to 90, and I'm going to create one more method called public void, let me just say just print data. So this is very important, right? Inheritance is a one where you get so many concepts to learn. So let's give some attention over here. So in print data, let me just print something called control.writeLine of this is parent. Fine. And here you have a parent. So now what I'm going to do in my main class, I'm going to create child object. OPJ child is. I'm not going to create any parent object, but rather I'm going to create a child object. Now here you can see I haven't inherited yet. Now how can I use inherit parent to child? This is something which we haven't done. So in order to inherit one class to other class, right, we will be using something called scope resolution operator, which is a colon, and then just say it as a parent. Now this is how we inherit a parent class into child. Now in this way you can actually inherit only one class. You can't have more classes like this. You can't do that. This is called as an inheritance. Now there is a relation between parent and child. Now when I create the child object, right, see what happens. Let's say I haven't inherited yet. Now what happens in object child? Just go and see, there are no variables and no methods which are there because I haven't written anything. But when you do inheritance with your parent, now see, go back to your object and see what happens. When you click, now you can see you have your variable, and you can see that your child which we have written, right, doesn't have anything, no variable and no method. But you can see what our compiler will do is, it will go and check first in child. If there is no data or no accessible variables or methods, then it will go to parent and it will get all the variables and the methods. Now you can actually use this print data. Now what it is going to do is, it will actually, now you can see I have created my child object, but I am accessing my parent feature. I can do it. So when I run this, let me just say it as console.read until unless it provides a key, I will move it close. I already have a main. That's why I can remove this. Let me run this. Now you can see this is a parent. But which object we use? we have used your child. Now this is called as your inheritance, where I'm using a class to other class. Fine. Now here, what I'm going to do here is, like, let's say I have, let me print the value of I here. So let me print like console write line of my value I, which is obj child of, that's what I do. So when I try to access I, what does it mean? See here, when I go to I, can you see on the mouse over it says parent.I, which means whenever I try to access, okay, right? So here you have I, which is your parent dot I. Now, which means I'm using my child object, but as I don't have any variable named I, it will go and search in parent. Yes, I do have it, which is a public. Then I will be able to access. Now let's run this and see. Now here you can see that yes, it is 90 over here. Now, okay, now you can see that yes, you have a I, which is I wrote I, which is 90, right? Got printed, and then you can see. Now let's move a step ahead. Let's say I am going to create int I is equal to some 400. Now first question is, can I do this? Yes, we can do this. Now, if you remember the scope of a variable, right? When I create I variable inside my child class, which means the scope of this variable will be, now again, I am talking about the scope of a variable. I am not talking about the accessing or accessibility of this variable. Yes, when I create a public variable, the accessibility of this variable will be in a child or across the outside program of child, or it can be across your libraries also. But I am actually talking about the scope, which means in my current class, if I have to use this variable, I can use variable only inside this class. But you can use this, if you create any object, yes, you can use it outside. Now see, I created a variable with the same name I over here, right? Which is, let's say this is I and this is I. Now whenever I call child.I, which I am actually calling? Now if you remember, as I said, whenever you have an object and whenever you are actually calling a method, now you can see when I mouse over it says child.I, right? Whenever I try to access any variable, first step it will go and search in an immediate object, and if it is not there, then it will go to parent. But here you can see that your I variable is already there in your direct object, which means it will get this value and not this. Now when you run this, you can see that part. You can see you are actually getting 400 and not the 90. This is how it works. This is how a clean way of inheritance is there. Fine. Now moving to one step ahead. Now let's say, even if you are looking for I, right? If you want to get forcefully a parent value 5, then yes, you can actually typecast your object and get the data. Now how to do that? Like typecasting, I hope you know this. So as we have done it for int and all, right? You can typecast it even for objects. I can do parent object where I am typecasting my object of child, right? And I. What does it mean? Whenever I typecast, the child object will become automatically parent, and now you can see when I run this, you can see I'll get it 90. Okay? Yes, if you want to force it and get this, you can do that. I'm not saying you can't, but in general, whenever you create an object, right, it will actually give you the child's object. So let me print the board. Right, now you can see first one will get a parent, and next one you will get an immediate one, which is your child. So this is how we can actually trace through the data. Now let's come back to method. Now you can see that you have a print data, right? And here you have, as you don't have any print method in here, right? Obviously, whenever I write a print data, whenever you call a print data using my child object, obviously it will go to parent because it doesn't have any. Now, can I write the same method name? Let me copy this signature. Now, can I do this? I already have a method parent in parent, but I am writing the same method again in child. Can I do this? Yes, you can do this. So let me copy this code here and let me call this view as a child. Now, what does it mean? It means that you have created a method again with the same signature in your child, which means you are trying to override, which is also called the method overriding. You are trying to override your parent method by writing the same signature method in your child, which means if you can see here, this will run the child. When I mouse over, you can see it says child.printed. When I run this, you can see it will actually get the child's method. Now this is called as an overriding of a method or method override. Now you have to do in some much better way. So whenever you are actually calling this, right, always try to use a new keyword. Now, like if you use a new keyword, right? If you use a new keyword, right? So what it is going to do is, now we know that we are overriding, but we are saying that yes, this is an override, right? It's a new override for this. Now this is called as a method overriding, right? So in this way, you can actually go ahead with any number of. Now this is called as your inheritance. The basic inheritance is this. Now let's go a step ahead. Now let me create one more class. So let me call it as class grandchild. I'm just creating so that you can actually relate things. So I'm taking the names. Right? Now what I'm going to do here is whatever I've done with the child, I'm going to comment everything. Now I'm going to create a new object called grandchild. Let me call this obj grand is equal to new grandchild. Now here you can see that I haven't written anything in my grandchild. And let me inherit this with child object. Right? Can you see now what I'm doing? I'm actually inheriting child class in my grandchild, and I'm inheriting parent in my child class, right? And parent is a super class. We normally call parent class as a base class and child class as a child class. Or in Java, we normally call parent as a super class. Fine. Now here, check this out, how it's going to work. Now let me first try to access a variable first. Okay. Console dot write line of, let's say I want obj grand dot I. Same way obj grand dot print data. See here, now this is a child and this is a parent, and this is a super parent, right? Now here I'm trying to access variable I and print data. Run this. See what happens. It will get data from its parent, which is child, which is I 400 and child. Now let's say in your child again there is nothing, which means your child also is empty. There is nothing in here. Now can I do this? Of course you can do it. Why? In some way or other, your grandchild is related to your actual parent through your child object or through your child. Now if you run this, you can see it is actually getting data from the main parent, I-90, and this is parent. Now this is how inheritance works, right? It will actually go into deep root till it gets the variable and the method accessed. Now, the summary here is if it gets access to variable or method, immediately in grandchild it will take. Otherwise, it will go to a step ahead. It will go and search in child. If it gets that variable and method, well and good. If it doesn't, then again child have got one more parent. It will go to the parent again, then it will get it. That's how it works. This is something which is called as a multi-level, which means I can have multi-level. Parent can be in child, right? Child, again I'm making in grandchild. Multi-level single inheritance, which means at once I can have only one inheritance, or one class can be inherited in one class. So this is called as your multi-level single inheritance. Now we haven't actually seen multi-level. What is multi-level? Now let me give you an example now. Let's say you have a class A which is inherited to class B, right? And B is inherited to class C. Now this is called as a single level inheritance. Single inheritance. What is multi? I can inherit A in some other class called D also, right? I can do that. Or I can actually access something called E class in here. I can do that. What does it mean? I am inheriting same class in different childs, E, D and D. So this is called as a multi-level single inheritance, which means at once when you come to D class, I am inheriting only one class called A. When it comes to E, I am inheriting only one class called A. B only. This is called as a multi-level single inheritance. Right? This is a inheritance which we have. Now let's go to a step ahead. Now here, let me go back to the main child. Let's say you don't have grandchild yet. Now this is very important, guys. Now if you remember, let me remove this parent and all. Let's just say this. Right? Now, if you remember, we were talking about something called constructor. Whenever you create any object of any class, right, it by default will create a constructor for you, right? You remember that it will create a default constructor for you in that class, and that default constructor will be called from your object. Now, which means your default constructor will have nothing, right? Obviously, your default constructor is nothing, but you have a method whose name is same as a class and which is public and it doesn't have anything. Like this, like let's say in your child, let's say you have something called public, you have a child, and that's it, nothing. Now this is called as your default constructor. If you don't declare your default constructor, then your compiler will create a default constructor for your class, and then it will be called automatically. That's how it works. Now there is a trick here. Now as I said, your class will have a default constructor, right? Which means even this one will have a default constructor. Let me just call that here. Oh sorry, it's parent, and this is your default constructor and your child. See what happens whenever we create an object of child. So whenever you create an object of child, the first thing what we know is that your child constructor will be called when you create an object, which means as soon as you create an object, your child constructor will have called. But if you are inheriting some class, then what happens is, yes, this will be called, but in this child, the first statement which will be called is your parent class constructor. First this will be called and then it will go back to your child. That's how it works. Now let me just print something in here and I'll show you that. Right line out, let me call it as this is a child constructor. Right, same way, let me copy it here and let me call it this is the parent constructor. And let's say I am going to comment everything. I don't want any other code here, let's say. Now I'm just creating an object of child where you can see, yes, I have a child and a child. Now as I said, yes, your child constructor will be called as soon as you create an object, but in your child, the first statement which will be called is nothing but your parent constructor. Let me run this. Now you can see the first line is a parent constructor, which means first it will call this parent constructor and then it will go to child. That's why they call this child constructor after that. And this is how it works. Same way, let's say you have constructor over here. You have public grandchild constructor. Right? What does it mean? It means that you have, let's say, console dot write line of this is grandchild constructor. Let's say. Now here, what is going to happen now? Let me create a grandchild object. Let me comment this out, and I'm going to create a grandchild object, which is, let's say, obj is equal to grandchild. Right? Now, which means whenever I create a grandchild object, it will go to the constructor of grandchild. What is the first line? It will be called. It will call child constructor. It will go to child constructor. Again, child have got a parent. What will be called? Your parent constructor. Now it will start from parent, come back to child, complete the child, and come back to grandchild and constructor. If you run this, you can see that your parent first called, and then your child constructor, and then your grandchild constructor. While the sequence will be maintained. Now you can see how best the inheritance is working. I mean, this happens only in loops, right? If you inherit things, then you can actually see this type of pattern, which is a very good, right? Now, let's go a step ahead again. Now we just said that if you write any constructor, or if you don't declare any constructor in your any class, your compiler will create a default constructor and it will be called. That's what we said. Now let's go to the next one. Is you can create any type of or any number of constructors you want. What does it mean? I can create something called parent with some, let's say, in some A. This is also possible, right? Because I can create a constructor with a different signature as this. So what do we call this? We normally call this as a method overloading. I am loading the same method with different signature or different arguments as such. Fine. So this is called as a, multiple constructors are different. Now let's say I don't have a default constructor. I only have a constructor which forces users to create object in a way that he should provide an argument. So Akila is asking some question. If we open that, in method overloading, is there any purpose to use same method in child? Usually we get another creating the same method. Yes, there is a there is a purpose that we create method overloading. Now, if you remember, let's say, let me just give you an example. Take an example of the same. I have a print data, right? I can create one more print data, void, let me just say, void, let me use the same name, print data. But what I'm going to do, I'm going to provide some string here. String, let's say S. So what I'm going to do, I'll print this same, but what I'll do, I'll add some string to this. Now these two are overloaded methods. Now how can I use this? When I create any parent object, right? See here, I can have, when I have print data, right? See, I can actually call print data in two different ways. Either I can directly call, or also I can say after printing that, just say how are you, something, I'm just printing. Right? Now here you can see if I run this, does not, okay. So we have actually changed the constructor, right? Let me just pass on some 5 because my constructor have changed and I think I have to change everything. That's fine. Let me make it default constructor enabled so that I'll show you how it's working. It is working, then we'll come back. Right? Now you can see I have actually called an overloaded method. When I run this, now you can see this is a parent and I'm also giving my own functionality to that. Right? Which means, see, I can do this by writing a different method, but it doesn't make sense. Why? Take an example of calculator itself, which you guys are doing. Now, if anyone want to forcefully give only 2 numbers, I want user to give only 2 numbers to sum, then you can write one method. Right? Let's say I'm going to write that. Let's say I'm going to write public void sum method where I'm taking int a comma int b. That's it, nothing else. But someone want to provide a set of details, like let's say public void sum, or let's say he want to give integer array, like he want to give a complete set of array to sum. Obviously he can call any one of them. These two are called as an overloaded method. So here what I can do, either I can actually call obj1 dot sum. You can see I can give two things. Either I can give 4 comma 6, right? Or I can give one dot, I can give something called, I can give array, right? I can mention some array over here. I can say 45, anything more. Now this is a different signature I'm providing, which is my integer array anyways. Right? I can define this integer array separately, like int array some o is equal to so and so, and I can pass an o. Right? Now in this way I'm providing same method with different functionalities. Now obviously you will have a major impact. If you are providing the same name but different functionalities, and obviously it's the best ever program you can actually give. That's how we can actually use method overload. Right, Akila, you got it? Okay. Fine, so it's cool. Then now let me just comment this. Now here, yes, we were talking about the parent, right? Let's say I don't have any default constructor. Now see what happens here. If I don't have parent constructor, you can see that you'll actually get an error in your child. Why? Because by default, your child constructor can call only default constructor of your parent. That's it. Because it doesn't know, if default constructor is not there, then your child constructor doesn't know what type of constructor you have used. Obviously, right? Now, in order to actually get rid of that, we have something called, what does it mean? We have to manually call our parent constructor. Now, if you already have default constructor, let's say, see here what happens. If you have a default constructor, you will not get any error. Why? Because it is already calling your parent constructor. How it works is, you have a keyword called base. Base is nothing but the object of your parent. Now anyways, base you can't define yet, normally we will see where it is defined. Now this base should be defined over here. Use an operator and say this. Now this is how we call parent constructor. Now here you can see I have two different constructors in the parent, right? If you go to base and just see, you can see you can call any of the constructor you want, which means I can call from my child. The parent constructor call can be anything. That's it. Now let's see if you don't have parent constructor. Then if you go back, you can see you have to call a constructor, but you have only one option to provide any parent. Let's say I'm providing something. Now this is here. Now here let's print that this is my parent constructor plus let's print a, which means whatever value I'm providing here, I'm printing. Now from where I'm getting this value, I'm getting from my child. Now this is how I get. But here you can see your grandchild, you will never get any error here. Why? Because your child, for grandchild, it's child parent, which is child is a parent of grandchild, right? It actually got some default constructor. That's why it won't get here. Now if you run this, you can see. So you can see here that this is a parent constructor and 8. Because again it will come from 2, and you can see this is a grandchild, and you can see this is a child. Now same way, let's say I don't have my parent or what is that? I don't have the child constructor, default constructor. Let's say I'm gonna give some other constructor here. Then what will happen? Then you have a problem in your grandchild. Now here it's very important for your base. Now you can get 1. Let's say I'm going to give some 100, which means it will call the base constructor of one type which accepts an integer. Now here there is one thing, the child accepts t, right? Now whatever argument you have here, you can actually pass that argument to your base also. I can say t here. Yes, it is possible. So when you send 100, it will go to child and you have a t. Now after calling this constructor, as I said, the first one which will be called is base. Now in that base I am passing t. If you go to this and it will be printing t. Come on, let's run this and show. See here, you have parent constructor 100 and child constructor and brancher constructor. Right? So this is how the constructor works. Right? Where it is mandatory to call your base constructor and then work. Only default constructors will be called eternal. Otherwise, it will be a problem, and you have to call your constructor exclusive. Right? So this is a complete, this is something which is a complete inheritance pattern which you have. Now here we have seen method overriding and method overloading, right? Method overloading, which means this is something where you are writing same method with a different signature in different patterns. And method overriding is, you can do method overriding only across class. You can't override method in the same class. What does it mean? I can't write the same method with the same name and same signature again in the same class, because it will give me an error. It will say that it will already, you have already declared it, and it will give an error. Right? So method overriding can be done only across related classes. A parent, I have print data. In my child, as it is related, I can do. Now this relatedness is called as, relatedness when you define different methods is called as a method overriding. And you can do method overloading in the same class or across classes also. Now this method loading and method overriding is called as your polymorphism, which we normally call multiple forms. A single entity having multiple forms is called as a polymorphism, where we have overloading and overriding as your method. So that is your polymorphism. It's a simple thing. We have explained here itself because we needed overloading because we have to do some different changes. Now this is your polymorphism and your inheritance. Right? So any questions? So this is a complete groups of encapsulation, inheritance and polymorphism. And tomorrow's class we are going to see what is abstraction. Again, this is something which is very important and it will be interesting. So these groups concepts are like pillars to actually write any class library or to follow some design patterns like a factory pattern or abstract pattern, any design pattern. OOPS is a base for everything. So try to go through this video again and to understand and all these three in much better way. And in next class we'll see what is abstraction interface. Good question. When you say base, right, it is not, yes, if you have, the base keyword have got its own significance. When you use in a constructor place, it will call your base constructor. But you can see if I use it here, let's say in my child, I have actually overridden my method, right? Here, if I want to call any of my parent method, let's say I want to call this parent data, what I can do here in my child, I can write base dot, you can see I can call that. Now base can be used in any way, right? I'm using this base here to call a constructor. I'm using base here to call a base class, which means parents class method, right? So let's say I have one more variable here which is public int j is equal to some 80, right? Now you can see here when I write in my here any method here, if I'm writing base dot, now you can see I, j, print data, sum, everything. Which means if you want to access anything, it can be a constructor, or it can be a variable, it can be a method, you can actually use base. That was a good question, Akila. Good that you reminded me, though, yeah, you can use that. Now again, if you go to grandchild, right, now you can see you have a base again. Now you can see you can actually access everything, like you can access from child and also you can access from parent. Now you can see in my parent class I have j, which is a variable which doesn't exists in child, but you can see still I think you can actually access that J. As you can see, you can actually access that. Yes, it's a keyword. It's a registered word in .NET which is used to call superclass or a parent class variables or constructors or any. Fine. Okay, good. So this is it for today.